spin. These are just a few examples of the many ways electricity powers our daily lives. Today, we'll delve into the fascinating world of electricity. Electricity, at its most basic, is the flow of electric charge. But what does that mean exactly? Well, think about it this way. All matter is made up of atoms, and these atoms are composed of smaller particles known as protons, neutrons, and electrons. Protons carry a positive charge, electrons carry a negative charge, and neutrons, as the name suggests, have no charge. In an atom, the number of protons and electrons is usually the same, balancing each other out and making the atom neutral. However, if an atom gains or loses electrons, it becomes charged. This is where electricity comes into play. When electrons move from one atom to another, it creates a flow of electric charge, which we call an electric current. Now, how does this current actually work? It needs a complete path or a circuit to flow. A simple electric circuit consists of a source of electricity, like a battery, a device that uses electricity, such as a light bulb, and conductive material, often a wire, connecting the two. But not all materials allow electricity to pass through them. Some, like metals, are good conductors, while others, like rubber or glass, are insulators. Conductors let electrons move freely, allowing the electric current to pass, while insulators keep the electrons tightly bound, preventing the flow of electricity. What about the force that pushes the electricity along? This is known as voltage, or electric potential difference. Higher voltage means more force, pushing more electrons along, and therefore a stronger current. In terms of measuring electricity, we have three main units. Amperes, or amps, measure the current, or how many electrons are flowing. Volts measure the voltage, or the force pushing the electrons. And ohms measure resistance, or how much a material resists the flow of electrons. In summary, electricity is the flow of electric charge, created when electrons move from one atom to another. It requires a complete circuit to flow, with conductors allowing this flow and insulators preventing it. The force pushing the electricity along is voltage, and we measure electricity in amps, volts, and ohms. So next time you switch on a light or charge your phone, remember the fascinating process behind it. It's not just magic, it's science. Understanding electricity is a step towards understanding the fundamental workings of our universe. Now, isn't that electrifying?